Today I'll be showing you how to solve systems of equations with elimination using multiplication. In this problem we have 2x plus y equals 23 and 3x plus 2y equals 37. This is different from using elimination with addition and subtraction because you actually have to multiply in order to be able to eliminate one of the variables. What I'm going to do to eliminate this, I personally, you can eliminate whichever variable you want. You can do the x's or the y's. I personally, in this equation, I want to eliminate the y's because I have a coefficient of 1 right here, so that'll be easy to multiply by. So if I want to eliminate the y's, I already have a plus 2y in the second equation, so I want a minus 2y in the first equation. One way that I can do that, or the way that I can do that, is to multiply this entire equation by a negative 2. When I multiply the negative 2, I'm going to get negative 4x minus 2y equals negative 46. When I combine these two equations, I'm going to get negative x, the two y's would cancel out, equals 37 minus 46 is negative 9. So I have to divide by a negative 1 here to get the x by itself. When I do, I get x equals 9. And now that I have that, that goes back to substitution. So I can substitute this x equals 9 in for either of the x's in the original equation. So I'm just going to put it back in the first equation. 2x, or 2 times 9, plus y equals 23. So I get 18, because 2 times 9 is 18, plus y equals 23. And I'm going to go ahead and subtract that 18 from both sides to get the y by itself. And I get y equals 23 minus 18 is 5. So my answer is 9, 5. That is my answer. In the second system of equations, you can see that all of my variables have coefficients other than 1. So I have a 4x, a 3x, a 3y, and a negative 5y. Now again, you can eliminate whichever variable you choose. You can eliminate the x or the y. I like to eliminate the y in this system because they already have different signs. So you can see the 4 and the 3 are both positive, but the y's, you have a positive 3 and a negative 5. And we know to eliminate a variable, you need a positive and a negative of the same coefficient. So in this problem, I'm going to multiply the top equation by a 5 and the bottom equation by a 3. And I'll tell you why I'm going to do that. Because the least common multiple for a 3 and a 5, as we see right here, this 3 and this 5, the least common multiple is 15. So how do I get 15? I need to multiply this 3 by 5 and this negative 5 by 3. So when I do that, I'm going to write my new equations down here. I would get 20x plus 15y equals 40. And for the second equation, I would get 9x minus 15y equals negative 69. So when I combine these, I would get 20x plus 9x is 29x. My y's cancel out, or they're eliminated. And then 40 minus 69 is negative 29. To isolate the x, I'm going to divide 29 by both sides, and I would get x equals negative 1. Once you find that, you can plug that into the original problem wherever there's an x. So I'm going to do it with the top equation. Again, you can with the 4x or the 3x. I'm going to choose just the top one. So 4x, which is negative 1, plus 3y equals 8. So again, you can see I'm plugging it in this equation. So I get negative 4 plus 3y equals 8. To isolate the y, I'm going to add 4 to both sides. And I get 3y equals 12. Divide both sides by 3. You get y equals 4. So the final answer for this problem, we're going to write as a coordinate negative 1, because my x is -1, and 4 because my y was 4. That's my answer. And the last system of equations that I want to show you for 6-4, you have 3x plus 4y equals 5 and 21x plus 28y equals 35. So you can see both of the x's are different and they're both positive, and the y's are both different, the 4 and the 28, and they're both positive. So it doesn't matter what you choose to eliminate. We know that if this is positive 21x, if I want to eliminate the x's, I need to make this a negative 21x. If I want to eliminate the y, we already have 28y here, so I would want this to be a negative 28y. So how can I do that? I'm going to choose to eliminate the x in this equation, so I'm going to multiply the top equation by -7, because that will give me a negative 21x when I multiply it out. Okay, so here we go. I'm going to distribute that -7 and see what I get. So I'll get negative 21x. -7 times 4 is negative 28y. And the -7 times 5 is negative 35. When I do that, let's see what happens. 21x minus 21x, that goes away. That's eliminated. 28y minus 28y, that is eliminated. And then over here, we've got 35 minus 35 is 0. So we have 0 equals 0 because everything ends up being eliminated. Now, we know that this is a true statement, that 0 does equal 0. So the answer for this one is all real numbers. That is your answer. So what does that tell me? Remember, with the system of equations, the answer is where those two lines meet. So if we have all real numbers are infinitely many, we know that this is going to be the same line on top of each other, which, going back to our first section that we learned about, would be considered consistent dependent.